Orbiting the magnificent gas giant planet, Jupiter, is the mysterious icy moon, Europa, a seemingly frozen world about the same size as our moon. With a surface temperature of about minus 160 degrees Celsius and a location that means it has to withstand a relentless pummeling of radiation, at first sight, it would be easy to think of Europa as a barren ball of ice. But despite the harsh conditions it exists within, this fractured moon is one of the most promising places to search for alien life. So how could life survive on such an extreme moon? And if it does exist, what might it look like? You're watching V101 Space. My name's Rob, and if you enjoy my videos, then remember to subscribe and tap the notification bell to never miss an upload. Many spacecraft have passed by Europa during their missions, but it was NASA's Galileo spacecraft that elevated our understanding of this icy moon to a new level. It discovered the first solid evidence that an enormous ocean exists beneath its surface. An ocean with possibly 2 or 3 times as much water as all of Earth's combined. Arriving at the Jovian system in December 1995 with the aim of exploring Jupiter and its large moons, Galileo passed by Europa multiple times, coming as close as 201 kilometers above its frigid surface. It captured its frozen terrain in incredible detail, allowing us to see close-ups of its cracks, ridges, and jumbled up landscape, but also find intriguing evidence of what might be happening below its crust. Galileo confirmed that Europa was geologically active. Its close-up images revealed the enormous cracks in the moon's surface had separated, and dark, icy material had flowed into the open gaps. As with the spacecraft that came before it, Galileo also found only a handful of impact craters, which are expected to build up over time as the surface is constantly bombarded by meteorites over billions of years, much like our own moon, for example. But Europa is smooth, suggesting that its surface is relatively young, and that something had erased any large craters, such as icy volcanic flows. One of the most important measurements made by the Galileo mission, however, showed how Jupiter's magnetic field was disrupted in the space around Europa. This measurement strongly implied that a special type of magnetic field is being created within the icy moon by a deep layer of some electrically conductive fluid. Based on Europa's icy composition, scientists think the most likely material to create this magnetic signature is a global ocean of salty water. There are even images from the Hubble Space Telescope that appear to show huge plumes of water vapor erupting from Europa's south pole, although unfortunately they are not high resolution enough to be definitive. But if Europa's surface is frozen solid, then how could a massive ocean of salty water form? And if there is liquid water down there, could life have really started in such a bizarre environment? While the icy shell of Europa is clearly frozen as hard as rock, the interior is warmer because it is heated by what's called tidal flexing. The side of Europa that is closest to Jupiter experiences a stronger pull than the other side, stretching the entire moon back and forth, probably causing the long cracks that run across its icy surface, as well as heating the interior through friction. Similar to how repeatedly bending a paperclip generates heat, for example. It is this constant flexing that melts the internal ice and creates Europa's enormous ocean. But is it really possible for life to start on a frigid moon hundreds of millions of kilometers away from the sun? Well, life as we know it seems to have 4 main requirements: liquid water, certain chemical elements, an energy source, and of course, time. We have already discovered that Europa may have an enormous ocean of liquid water that is protected below its crust. And certain studies of the ocean have suggested that it may have formed just a few 100,000 years after the moon formed. which is estimated to be around 4.5 billion years old, giving life, if it does exist there, plenty of time to get going. But what about the other two requirements? Chemical elements and an energy source. Chemical elements are the building blocks of life as we know it, and they include carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements are common throughout the universe and make up 98% of living matter on Earth by combining to form organic molecules essential to life. Scientists think these elements were likely present during the formation of Europa, and may have even been added to later on when asteroids and comets collided with the icy moon. One good example of chemical elements discovered on Europa was made fairly recently when the James Webb Space Telescope detected large amounts of carbon dioxide on its surface, as can be seen in this incredible infrared image. Europa is shown as blue, while the carbon is white, and it is thought that it likely originated from the ocean below. Then we need an energy source. All life as we know it requires it to survive. Here on Earth, life relies mainly on the sun for energy, such as through photosynthesis. Plants convert sunlight into energy, allowing them to grow, and that energy is then transferred to those who eat the plants. But any life that may exist in the ocean of Europa is hidden below the thick ice. No light can penetrate through it, meaning that a process like photosynthesis couldn't work. Instead, life would have to be powered purely by chemical reactions. And these reactions could come in multiple ways, such as from Jupiter's powerful radiation that is bombarding Europa's surface, or perhaps more likely from the warm rock at the sea floor. As the icy moon orbits around Jupiter, its interior flexes, as we have already discovered. The flexing forces energy into the moon's interior, which then seeps out as heat. The more the moon's interior flexes, the more heat is generated. If Europa's rocky ocean floor is heated by tidal flexing, that process could potentially be supplying energy in the form of available chemical nutrients in hydrothermal vents. And this type of process can be seen here on Earth, where life is abundant. The vents are like bubbling cauldrons of energy, spewing out super hot water that has flowed below the Earth's surface, becoming heated by a layer of molten magma. They erupt with plumes of what looks like smoke bellowing out of a chimney, but within it is a soup of chemicals that certain life can thrive on. The chemicals would be toxic to human beings, but these organisms can convert the chemicals to energy. This process is called chemosynthesis, and is what ultimately powers entire ecosystems around hydrothermal vents found in the deep dark regions of our oceans, the places where the sun's light cannot reach. The vents are the only places on Earth, in fact, where the ultimate source of energy for life is not sunlight, but the Earth itself. Huge red-tipped tube worms, ghostly fish, strange shrimp with eyes on their backs, and other unique species thrive in these extreme deep ocean ecosystems. So life as we know it on Europa, it seems, could be possible, but what might it look like? To get an idea, one place we could look is within one of the deepest, darkest points on Earth, the Mariana Trench. The deepest point in the Mariana Trench is called the Challenger Deep and is 11 kilometers below sea level. It is difficult to comprehend how deep that actually is, but if you placed Mount Everest there, the peak of the mountain would still be more than 2,000 meters below sea level. However, that's nothing when compared to Europa's ocean, which is anywhere between 60 and 160 kilometers deep. But despite this enormous difference in depth, the conditions between the two environments may still share some similarities. Imagine a vast, seemingly endless, pitch-black void filled with crushingly cold seawater. This is the type of oppressive environment life within the Mariana Trench has had to adapt to. But dive deep enough and you will find some of the weirdest creatures on Earth. Creatures so strange that you would think they were from Europa. Take the snailfish for example, a species that breaks the record for any living vertebrate. It is the deepest living fish ever discovered, found at more than 8,000 meters below sea level. This weird, translucent, tadpole-looking fish is known to contain chemicals which help keep its membranes and cell walls flexible so that the crushing pressure doesn't kill them. But there are creatures that live deeper. Within the deepest region of the Mariana Trench, the Challenger Deep, 3 organisms are most commonly found. The first are called xenophyrophores and are the world's largest single-celled organisms that resemble spherical or frilly sponges about 20 centimeters across. It is unsure exactly how these weird creatures survive, but it is thought that they produce slime that soaks up microbes from the sediment around them. Then there are anthropods, which are shrimp-like scavengers that survive the deep seas because of exoskeletons that contain aluminium. How these little creatures find this metal is a mystery, but scientists think they use sugar-based chemicals in their guts to extract aluminium ions from the sea floor as they feed on debris raining down from above. The third are called holothurians, which are a species of deep-sea sea cucumber. They are the most alien of the known animals in this region and are highly diverse, appearing with spiky, brightly coloured skin or smooth, translucent skin. Vast fields of sea cucumbers have been discovered at the bottom of the Mariana Trench, like cows grazing over pastures as they feed on bacteria and decomposing matter on the sea floor. So if life has managed to thrive in the deepest oceans of Earth, could it have also done the same in the even deeper oceans of Europa? Until we send a probe capable of drilling through the thick layer of ice that encases it, we may never know. Europa could be full of alien creatures, or it could be completely barren. However, that burning question may be answered in the next few years, because the European Space Agency, along with NASA, each have 2 separate major missions to Europa. The first, from ESA, is called JUICE, and has already launched in April 2023, arriving in 2031 with a double flyby with the aim of collecting new data on the chemistry of the icy moon. Then we have NASA's Europa Clipper, which is a mission designed to determine once and for all whether this icy moon's ocean is habitable or not. It is scheduled to launch in October 2024, but won't arrive until April 2030. The exciting missions should complement each other, but neither will be able to confirm if aliens exist there, just whether the icy moon has the right conditions to support life as we know it. If we did eventually find some form of life on Europa, it would probably be in the form of microbes, surviving around a hydrothermal vent. But if it can be demonstrated that life formed independently in 2 places around the same star, regardless of how complex it is, it would then be reasonable to suggest that life springs up fairly easily once the necessary ingredients are present, and that life might be found throughout our galaxy and the universe, meaning that we are far from alone. I really hope you enjoyed this video. If you did, then please tap the like button and subscribe. There's loads more to watch. Thank you all so much for watching, and I'll see you all next time.